Okay, let's look at both definition and an example of calculating the third measure of center, the arithmetic mode. And once again, we're looking at a situation where we're dealing with datums that are continuous, meaning they're measured. Now, what makes the arithmetic mode a little different than calculating the arithmetic mean or the arithmetic median is that if you have continuous data, uh, datums that have decimal places of accuracy, even if you have that data, you cannot run like a spreadsheet mode software on it. I mean, you can, but it's going to give you the wrong answer. The only way that you'll be able to calculate the arithmetic mode is going to put it into a histogram. And then once the data is put into a histogram, then you can calculate the mode from that histogram. Okay. And the reason for that, I'll explain really quickly, is that when we're dealing with discrete data, all right, which are counting numbers. So, we might have 4, 5, 6, 6, 7, 7, 7, 8, 8, 8, 8, 8, 8, 9, 9, and so on. It's pretty clear, by looking at this that we can go, well, there's 6 8s here, and that's the mode. But when we're dealing with continuous data that has decimal points, you might have 137.5, 137.7, 138.1, and so on. It's going to be rare that you do have two data points that are, or two datums that are going to be equal, like what we had equal eights, and we could count the number of those eights. We may only have 137.5. We'll have another measurement, which is close, but it's still not the same. So that's where trying to calculate the mode of continuous data is so difficult. If you use Microsoft Excel or Google Sheets and you use the mode function will work with something like that, but it's not going to work correctly for something like this. And so when you're using the arithmetic mode, when you're trying to calculate the arithmetic mode of a data set, you want to do it regardless of whether you're given the datums or not given the datums. You want to use this in both cases. Okay. So this arithmetic mode you'll use regardless of whether you have the data or you don't have the data, and you only have the histogram or the frequency distribution table. The other caveat of using the arithmetic mode is, you could have a case like this one. So this is a case with only one mode. This is where you have one class with the highest frequency. So what we got here is we have a bunch of classes where only one of them has the highest frequency. Okay, that's what we got here with this class that has a frequency of 32. But it's possible you could have a data set that has more than one mode. So again, you can use the arithmetic mode with this case, of course, but you could also have one that's got two modes. And so an example of that would be, here's your classes, and you have two modes that are identical and they're adjacent. So maybe this has a frequency of 13 and this has a frequency of 13. Identical frequencies. This arithmetic mode will work in this case. Okay, this is a special case. It will work. And you're going to identify the first of these two as your modal class. All right. Now, the third case that you might see, again, you've got two modes, but they are non-adjacent. What do I mean by that? Is you'll have two modes that are not side by side. They could have one class separating them, something like that. So even though these two classes have the same frequency, you cannot use this formula of the arithmetic mode because they are not adjacent to each other. Okay, so we've got two modes and they're not adjacent, so we cannot use this formula in this case. This is going to be what's called ill-defined. And there is another equation that we'll look at next for calculating the mode with an ill-defined distribution. Okay, so I want to be clear that the arithmetic mode, again, is to be used whether you're given the datums or not, and when you're dealing with one mode or two modes that are adjacent to each other. That's when you want to use this equation. All right, so having said that, I also want to point out, that there are these links, as I've talked about before. If you want more practice, with this type of problem, you can click on those links and you can have some MyOpenMath problems crop up and you can check your answers and get new problems so you can master this technique. So let's now kind of dive in and actually look at how to calculate the mode here. So here's the equation for calculating the mode. And so again, I think this will look intimidating, but once we start identifying the pieces here, I think you're going to see it's really not as intimidating as it looked at first glance. Each of these variables in the equation, I've described what they are here off to the side. Okay, so let's kind of dive in and look at finding the arithmetic mode of this distribution that we've got up above. So again, let's start with the easiest first. And so the first thing is we can get the width. And the width is going to be the difference between the upper bound and the lower bound, or between midpoints. So here, the difference, and we're dealing with the same data set. The difference here is going to be 8. So the difference between 330 and 338 is 8. Or we can look at the difference between midpoints. So the difference between 310 and 318 is also 8. All right, so we have our width, which is that part of our equation. Now the next step is to identify the modal class. And so the modal class is the class with the highest frequency. All right, and in our case, that's going to be class 7. So if we come over here, it's probably easier to see with the histogram on the right, and that the modal class is the class with the highest frequency. The highest frequency is 32. So this class here is our modal class. So let me do this. I'll put modal class. And the class with a frequency of 32 is this one. It's the 7th one. Okay. So that was pretty easy to do. Okay, just by looking at the picture, we could figure that out. Let me get rid of that. And let me undo that back. There we go. Go away. There we go. All right. So the next step is now to find the frequency of the modal class. So the frequency of the modal class is right here in the equation. And so what was the frequency of our modal class? It was 32, right? So that's the frequency of the modal class. The next thing we need is the frequency of the preceding class. So what was the frequency of the class immediately before the modal class? That's going to be 31. So that's this one right here. Next, what is the frequency of the succeeding class? So the succeeding class is the one after the modal class. Okay, that's going to be 21. So 21 is the frequency of the succeeding class, the one after the modal class. So there's no calculating to do, it's just finding it in the picture. And the last bit of information that we need, the last bit of information that we need is the lower class boundary of the modal class. So what is the lower class boundary of the modal class? Well, we can go up here. And so our modal class was 7, and the lower class boundary is 282. So it's 282. And so what we've done is we've identified all of our variables. We had the frequency of the modal class, okay, which actually goes in 2 places, there in the numerator and also in the denominator. We have the frequency of the preceding class, which goes there and there, the frequency of the succeeding class, which goes there, and the lower class boundary of the modal class. That goes there. And now we've got all the numbers we need to plug into our equation. So what you're seeing down here is that equation with those values plugged in. And all I did was just successively, simplified it to get our mode, our arithmetic mode. This picture that I put off to the right are all of the pieces for this equation that I identified up above. Okay, I just kind of did it a little bit more formally here. So once again, I want to reiterate that number one, this equation, the other equations, these will be given to you on the homework and also for the exam. So you don't have to memorize these formulas, but you will know how to know what they mean and what the parts, what those variables mean. You won't have the definitions to refer to. You'll have to practice this enough to know what those variables refer to. And that'll just come with practice. And that's why I provided these links up here so that you can practice for mastery. Also remember that the arithmetic mode is a different, you want to use it pretty much in all cases, regardless of whether the datums are given or whether they're not given. And you can use it with a single mode or with 2 modes, but the 2 modes have to be adjacent to each other. You can't use it in this case where you've got 2 modes that are non-adjacent, where they're not side by side. All right. Well, let me know if you have any questions.